Hello everyone, my name is Muhammad Hinar from Browan Communications. This will be a short educational workshop which I will be speaking about the internal antenna design process. So this will be based on my experience in the wireless industry for the past 10 years. As we all know, in IoT space, devices have strict limitations in terms of size and dimension. So in this workshop, I'll be guiding you through the whole process from choosing the best type of internal antenna, and then we'll take you to what we were going to do is we will show you how we use our simulation software tool, and then we will go to antenna chamber to do some testing there, and then we'll do some real-time testing. So for this workshop, we are choosing to demonstrate to you our latest LoRaWAN gateway, which is a femto-light indoor gateway. So for this case, we have an existing enclosure that was ready before we kicked off the project, and what we did is we took off this enclosure and then we designed the antenna based on that. And if you see, this is now is a ready product. What we have here is two types of internal antenna. One is LoRaWAN BIFA, is a LoRa BIFA antenna, and over here we have a Wi-Fi antenna. So please make sure to stick around and watch till the end. Stay tuned. Thank you.
I will be using the femto-light gateway to demonstrate this workshop, which is one of our newest products to be launched in 2021. The femto-light is a LoRaWAN indoor gateway with a Wi-Fi and Ethernet backhaul connection. It supports LoRaWAN 1.0.3 packet forwarder and basic station protocols. You can easily switch between modes using the web GUI that we provide to you. This gateway is a very low-cost gateway with a built-in antenna. This will be shown later on. The gateway is using ESP32 platform, and it's perfect for indoor uses like smart building or homes. It's also very suitable for small businesses or private use cases like parking spaces, exhibition center, campuses, etc. It is also suitable for providing coverage for indoor and blind spots. As I mentioned previously, this gateway has both Wi-Fi and Ethernet backhaul, and the gateway has two built-in types of antennas. Let me try to open this one and show to you. Yes, here you go. As you can see, we have two antennas in there. This is the LoRa BIFA antenna, and over here we have the Wi-Fi BIFA antenna. Here's a closer look into the internals of the femto-light gateway. So the size of the circuit board is about 11 centimeter long, and we have by 9 centimeter wide. The enclosure height is about 27 millimeter, which gives enough space to place a BIFA antenna. We see here we have two antennas. On this side we have the LoRa BIFA antenna, and over here, I'm not sure if you can see it, but we have the Wi-Fi BIFA antenna. And if you look closer here, we keep them in a keep out zone or keep out area over here and over here. Or what we say, we give them enough grounding where there are no electric components nearby, so we prevent any interference. Because if you look over here or over the side here, you'll see there are no any electronics components placed or mounted nearby them. For those who are new to the antenna industry, BIFA antenna stands for planar inverted F antenna. If you look here, it looks like kind of F-shaped antenna, and it consists of a monopole antenna running parallel to the ground plane and grounded at one end. If you look here, it's grounded at one end and over here as well. The design of BIFA antenna has two advantages over a simple monopole. The first advantage we have here, that the antenna is shorter and more compact, and probably I'll take it and just show quick to you The one over here, this is the Wi-Fi one. And if you look here, this is the BFA F antenna. It's very simple design, it's F-shaped, and they are grounded at only one end over here. And I'll put it back now, and the other advantage we have, or the second advantage we have of having a BFA antenna, is the impedance matching can be controlled by the designer without any need for extra matching component, not unlike other type of antennas. So the BFA antennas is not like other general components that you just could buy them off shelves or from the market. In most cases, I would say 90%, you have to customize and design them to fit within your design. I'll take a look into another BFA design within another gateway. If you look here, this is a smaller gateway, or what we call it, a wall-like gateway over here in this side. So this is the gateway here. And we have also a LoRa BFA antenna here. But if you take a look here, this is a smaller one. And the reason why it's smaller than what we have in the FinToolite gateway is that we have limited space and not enough grounding for the antennas to be placed in, and that's why we have to develop a smaller one. And of course, when you have a smaller one, there are different gain, and of course that will result into a different range, coverage, and performance. Worth mentioning that there's also another type of antenna, of internal antenna, but I will not go deep into this one now because our focus will be on the BFA internal antenna. We have also in printed antenna, which is printed on the circuit board. Probably this one you can't see it by a normal eyes, but it's printed within the PCBE here, and that comes for smaller IoT devices where you really have very limited size and space to place an antenna.
Right here I'm showing you the enclosure of the FemtoLite LoRaWAN gateway. We have designed the antenna based on this existing design. This is LoRaWAN gateway with the Wi-Fi backhaul, so we have two BFA antennas. I'm also showing you the PCBA and the groundings, as they are very essential factors to the antenna performance. For just the knowledge, internal BFA antennas provides a pattern that's more spherical and stretches in any direction. You will see the pattern is influenced by how grounding has been done and the size of the circuit board in the unit. Therefore, it's not entirely spherically shaped, but it will be distributed the signal much more evenly than external antenna. Now, I can simulate the antenna radiation pattern. As I mentioned earlier, the internal antenna gives you a coverage almost shaped like a ball, thus provides more complete coverage. The blind zone is minimized and also provides you a better conditions for multipath technologies, and this is what we need for IoT devices and for indoor usage of gateways or devices. Now, worth noting that internal antennas are better for indoor usage as wireless clients, that said mobile phones, computer, and other IoT devices. And also for the BFA antennas that we are using in this gateway, it has an efficiency of around 75. Now for the next part will be the antenna chamber. You see our engineers walking to the antenna chamber to set the device there. This gateway has two antennas, LoRa and Wi-Fi antennas, so the and we will be testing one type of protocols at one time. So and this time we will be testing the LoRaWAN protocol. So we will tidy up the gateway properly in order to make sure not to fall down during the process, as this test will involve circling the gateway for 360 degrees for two different angles. First for the PHI angle and 180 degree for the theta angle. At first, the theta angle will turn 15 degrees each time, and then the PHI angle will start turning 360 degrees. After placing the device into the antenna chamber, we will define the test specification on the computer with the testing program. Just for your information, we are using
attend lab Maxwell, we will start inputting the desired frequency band. In this case, we are testing the LoRa antenna, so we will be testing US and EU band at one time. So we will select the test frequencies. We selected the 860 megahertz up to 930 megahertz, and we're testing every 5 megahertz in this range, as you can see. Just for further knowledge, the chamber wall is covered with EMI noise absorber, which can reduce the interference of the reflections of the electromagnetic waves that isolates the external signals. And we started the test now. The test program will start showing you the volume of the antenna gain during the test. So if you can see in these lines here, you see the different colors, which will show you all the different frequency we set before the test and the antenna gains based on the test. By the end of this test in the chamber, we will start getting the test results, which are generated in two files. One is an Excel file, and the other one will require transforming the data from Excel file and create a 3D graph of the performance of the antenna.
The last stage of this workshop will be about the real-time testing. We are bringing the FIM to Light gateway into the field to do some testing in terms of range, coverage, and also the received and transmitted speed or traffic. Right now we are in a concrete 9 floors building, so we will be installing a Wi-Fi router as an access point at the first floor. Then we will use the FIM2 gateway to test the signal from different ranges and distances. We probably will be in the first floor or ground floor, and we will move outside of the building and also different floors within the building. And the test range or distance will be between 10 up to 100 meters. And by then we can see the test result. Please note this is an antenna design workshop, so we can talk about different types of antennas, and for this particular case, for the field testing, we are focusing on the Wi-Fi antenna range. Upon completing the testing, we can see that we get the test result, and we can see the test report of the transmitted and speed from the FIM to light up to the Wi-Fi router, and we see here the range for different distances from 10 meters, 30 meters, up to 100 meters, and all looks pretty solid and good, all in the range of 50 and above megabit per seconds. And also in the received traffic from the router to the FIM to light seems as well pretty good, and we can see that we are getting about traffic of in the range of 42 up to 45 megabit per seconds. So that's all about our workshop. I'm sorry if this has been very short, but we tried our best to combine all the necessary information in 15 minutes. And if you have any questions or you would like to inquire more, to learn more, please feel free to leave your comments here or reach out to us. We will be happy to guide you and explain more to you. Thanks for listening, and wish you a happy year.